Miss that little important part, it would make this problem a lot tougher. Kind of trying to figure out what they're comparing and what they're mentioning. So I'm going to kind of highlight that again if you have a hard time reading this because it's so tiny. It basically says in age range, colon, not in age range. Okay. And we're looking for the 25 to 35 years. And they give us this nice little key that shows us what that is. So the 25 to 35 is the dark, completely filled in black there. So the age range that we're looking for is this 25 to 35. So that's 42%. What are the odds, so the percentage, that they're in that age group, colon, how many are not then? So the 42% is in the age range. How many are not in the age range?
58.
58. How'd you get that number?
100 minus 40.
Yeah, this is talking about percentages. The whole percentages, all of them should be 100. So if some are yes and some are no, they should add up to 100 altogether. There's not like a questionable age range. Like, I mean, it's either you're 25 to 35 or you're not. There's not like another like category that you like don't want to tell your age or something. So he said out of 58. Because that adds up to 100, so either yes or no, they are or they aren't. But if you look, that doesn't show up on here. Why not?
Because you can simplify.
Yeah, you can simplify that. 42 to 58 is not on here. So hopefully you're not just going to guess the one that has a 42 in it because it's on there. We can simplify this. Essentially, this is just a fraction. Colon on odds, or it's a fraction, it's just a percentage. We're just simplifying this. We can divide these each by 2, I think.
They're both even, right?
Yeah, they're both even. So 21 to 29, and now that's one of our choices. So it's like 20 or 42% chance that they are in the age range, 58 that it's not, but they simplify that ratio. So it's pretty close to even, that it could go one way or the other. So pie charts, again, I grabbed this again from a practice ACT, show it up in all sorts of places. This one, they kind of combine that idea with probability, so it's worth us talking about, especially in this chapter. So what we're talking about today is mean, median, and mode. And I know you guys have learned this a bunch of different times in your life, but at the same time, it's something that does come up pretty often in different areas of work and life, and just it can be something that we can use. Now, if you look this up somewhere, somebody might use the words measures of central tendencies. So just that you guys know, if they mention that, that's all this, like those 3 fall under that category. So central tendencies is what it's called. So we're going to talk about those today and practice mean, median, and mode. And like I said, you probably have learned them a bunch of different times. They come up, like I said, in a lot of places. So do you know what mean is? What's a better word for mean? Yeah.
Average.
Average. So not by 100.
By how many there are.
Oh, sorry, I thought you said 100. Okay. So average is what mean is. So what Clayton said was we add up all the values we have and we divide by how many there are. And we divide by the number of entries. So if I'm trying to figure out our average score on a test, I would add everyone's test scores, and then I would divide it by how many students we have. Like, what's the average of all our test scores?
But what if the student's absent?
Well, yeah, so that's the question then. Do we put it as a 0? How does that work? And so we'll kind of talk a little bit about what happens when kind of weird things happen in these cases. We're going to get into this a little bit more and kind of trying to break down the data and make sense of it. Because if you look at this question, it's not just asking us for the mean. It says students sold candy bars for an upcoming trip. One student felt they worked much harder than all the other students. So let's say they're pooling all their money together. So one student said, I've been working way harder than everybody else. Use the mean of the numbers and the mean of the numbers excluding the highest to argue that that student worked significantly harder. So basically, let's figure out the average, and then let's figure out the average had that student not sold any candy bars, and kind of, or like take them out of it, and kind of show that they were kind of carrying the team. Like that they were doing more work than everybody else, and that we kind of, you know, maybe they deserve more, maybe they need to earn.
Maybe they deserve first class.
Right, yeah, they get the good seat on the plane, I don't know. So, all right, so we're gonna find the average of all the students, or all the candy bar sales. But then we're also gonna find the average if we excluded that highest one to see like how that impacts if they weren't part of it. So if we add these all up, so we're gonna take these 5 numbers and add them up. And you don't have to show this, I'm just trying to have it for our notes in case. But then we're gonna divide by how many entries there are. So in this case, there are 5, right? Now be careful in your calculator. When you do this, you do have to enter after you've done all that addition. Otherwise, you're just gonna divide the last number by 5. So you're gonna wanna add them all up. So I get 166, leave, and divide by 5. Okay, so we got 33.2 as our average. So that was the average of the sales among those 5 students. So let's take that other student out of it to kind of show that we kind of needed them, so they did more. So exclude the highest. And we'll talk about when it's useful to exclude the lowest. Like every once in a while you might have a teacher that says we can drop your lowest grade. That's nice when that happens. Here let's take that highest student's totals out of it and see how much we sold. So we're gonna get rid of that 65. But we're only dividing by 4 this time because we're taking that kid completely out of it. We're not assuming he didn't sell it all, like that he's a 0, and dividing it among 4. So we get 101, divide by 4, so we get 25.25. So kind of what we're trying to get at here is that he could probably argue, without me, you guys only got, or you got only to 25 candy bar sales or whatever, is your average. When you threw me into the bunch, I got us up to a 33. Had everyone done that, we could have like doubled our amount. You know, like, so realizing that without him, they weren't doing very well. With him, like, the average is still not great, but he was kind of carrying the team there. He's doing a lot to help out. So if more people had contributed, that would have been useful. So sometimes ignoring one of the data points and kind of throwing that out is important, because this is probably a better indication of how everybody else did. Everybody else did about 25. When he put his in, 65 is so much significantly higher than 25. I mean, obviously he's doing a heck of a lot more than everybody else. All right, so that's mean to find the average. Weighted average is something we do actually pretty frequently. We actually, when you guys are figuring out like your GPA, you actually kind of do a weighted average. We'll show that in a second. But a weighted average is when something repeats. So if there's multiple values at that same point, we have to kind of multiply it multiple times here. So so there's repeated entries. So we want to make sure we list things multiple times, and so we're going to kind of do that in a short way to kind of help us with this. Now the weighted mean is still just the mean. We're still finding the average. It just means that some get more counts because there's more of them. So in some like fancy neighborhood here, we have these incomes. There's 12 families that have $75,000 as their family's income. 15 families at $90,000. And 5 families at $105,000. Now, if we just took the average of those 3, that wouldn't give us the average of the community. It might be close, but we don't know for sure because there's 12 families that make $75,000. So what we're going to do now this time is we're actually going to multiply that. We're going to do 12 times 75,000. We're going to do 15 times 90,000. And then we're going to do 5 times that 105. But how many are we going to divide by?
32.
What's that? 32. There's 32 total families. So we're dividing it among the 32. So there's 32 families in this neighborhood. We're trying to find the average income for all 32 families. So if we put them all together and average that, what we'd end up with. Now just be careful about, and I really suggest you guys put this in your calculator and make sure you guys know how to do that. That you're not just like following what I have here. And double check, because I can enter something wrong and I want to make sure that you know how to enter it so you're not asking me the day of the test. Now, I'm hoping to find a number that makes sense for an answer. So like part of averages that I really like is that my answer should make sense. 86,000 sounds about right for average. If you guys look, a whole lot of families are at 90,000, a lot are at 75,000. There's a smaller number at 105, so I'm anticipating it being close to that 90,000. But the fact that it's pulled a little bit more towards the 75 makes sense to me based off of the data. So if I had gotten an answer like 40,000, I hope that I'd be like, that sounds wrong. You know, so like making sure my answer makes sense. Did you guys all get that as well? So again, weighted averages shows up if you guys are trying to figure out your GPA. Now, there's going to be a question in your homework that's going to talk about different numbers of credits. So just that you guys know, we typically, our classes aren't like weighted, like your GPA isn't based off of weighted credits. All our classes are worth the same amount. So like in college, if I have a 4 credit class and I get an A in there, it's worth more than like a 3 credit class. Like, you know, like so you get more credits and more points towards your GPA. Now, since everything is worth the same here, but when we're figuring out grades, A gets 4, B gets 3, C gets 2, D gets 1, and you get 0 for F. And so you can figure out your GPA by using this weighted average, except it's going to be a little bit different in this case. So they have an A in English. So for English, she gets 4. So we're going to call it a 1 credit class, so she gets 4 for that. A C in biology, so she only gets 2 for that. A C in history, so she gets 2 for that. And then a B in math, so she gets 3. Now, if these were different credits, we would multiply by that. So if you got more credits for English than you did for math, you would multiply it by that number as well, and then talk about the total credits. But we just get to add these up, so we get 11, right? And we're going to divide it by our 4 classes. So we'll figure out a GPA here, which is a 2.75. So that's in between a B and a C. It's a little closer to a B than it is a C, so likely it'd be like a B minus average. because actually B minuses, C pluses would get different point values than those. Like they do get little decimals for having like an A versus an A minus is a difference in your GPA. So it's worth trying to get it up if you can. Okay? Questions there? Let me flip this over. The next thing we're going to talk is median. You know what median is? The middle number. So it's the number in the middle. So the short way to say it would be the middle number. But what we're going to do is we're first going to put the numbers in order. So we're going to put the values in numerical order. Then we're going to find the middle number. So we're going to look for the middle numbers. Sometimes it means counting back and forth on each side. Now, if there's one middle number, that's the median. If there's two middle numbers, we have to find the average of those two. So we're going to break this down into two steps. So if there's one middle number, that's our median. If there's two, we have to find the average of those two numbers. There's two middle numbers, we're going to find the average of the two. So our test scores in pre-calculus were as follows. Now, technically these were not my test scores in pre-calculus, but I just used them for. We can go low to high, high to low, whatever is the easiest. I don't know. So we have to put these in order first. Let's go low to high. What's our lowest number? 37. Now what I like to do is cross them out as I go so I don't forget about it. Probably putting them in order is probably the most tedious part. I see a 52 out there. Do you guys see that? What do you guys see next? 67. 67. 77, is that next? 80. 388s, yeah. Whoops, 888. That kid's amazing. $90, right? There's two 90s. Two, 95 and 100. Okay. What I think is easiest is to count, take half of that, and then count over to that. Otherwise, I've seen some people that count from either side and kind of try to go to the middle. It's kind of crazy when there's this many numbers, but how many are there? There's 19. So the halfway point, halfway of 18 is 9, so that it's going to be an odd number. I should have grabbed one that had even so that we could check the average thing. But so I'm going to count up 8. Wait, no, 9. 1, 2, 3, 4, 5, 6, 9. So is this it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like 84 would be our middle point. So there's 9 on either side. So the median would be 84. Why would the median be a useful data point? Why would this be helpful? Anyone have any ideas? Yeah?
Outliers.
Outliers. What do you mean by outliers? But you're right, but yes.
Meaning it'll calculate just basically more in the middle of the data instead of, it doesn't really take into account too much outliers.
And what do you mean by outliers? Because you said that, but I just want to make sure everyone
just numbers that are far off the more average window of data.
Like who would be an outlier in this one? 37. So if I was trying to talk about my data and see how my kids did on a test, like how did my pre-calc students do on a test, the 84 might be a better indicator than working with something that would involve that 37. I actually am really, not maybe very quickly, but I was going to find the average to show you guys the difference. So, because I've had, I once had a parent ask, like, what was the average score on the test? And I actually said, I actually wouldn't be comfortable telling you the average score. I'd rather tell you the median score. And the reason I said that is because I had some outliers. I had students that did really poorly on the test, and I didn't think it was fair to count their score in my overall average. They weren't really trying very hard on that test. And I wanted to show, so the average, if the mean in this case, would have been a 79. So that 37 pulls that grade down so much because 37, that's a really low score on a test. I mean, like as much as I really wish I could reach every single student that I teach, that 37, I don't know if there was anything that I was teaching that kid was gonna be like, yeah, I got this. Like, I mean, I hate to say it, I don't think that kid was trying very hard in that chapter. I'm just gonna throw that out there. If they got less than half the points on the test, I don't want that to affect my overall average. This is a better average. 9 kids are above, or 8 kids are above, not 8 kids are below. That middle number, it's kind of showing this is what the regular kid would have got, the middle kid. He's so cute, or she is. So, the median, again, it kind of like takes outliers out of it. So like those really far extremes, it kind of removes outliers. Now, the median might not be the one you'd want with the candy bars. So the candy bars, the median probably would have been
Very high.
actually no, it would have been low because there were so many like in the 20s and that 65 kind of got ignored then. So it kind of removes those outliers from it. So sometimes the median is actually better data than the mean, depending on the situation. It kind of takes out if you had that bad day, like it kind of like ignores that a little bit. It just counts as a bad day versus something that shows up a lot more often. All right, and then mode. You know what mode is? Yep.
It's the most common individual number.
Yeah, most common occurring. So what would it mean if I said we had no mode? Everything happens once, nothing repeats, so there's no repeats. And the last term is bimodal. Bimodal, what do you think that is?
Where 2 would have the next.
Yeah, so 2, maybe 2 or more repeated, so that is possible. More than 1 repeat. So let's look at the mode for our data here. So let's look at the mode for our test scores. So what's the most often occurring test score for my pre-calc class here? So it was 88. There was 3 88s. So 88 would be my mode. There were other ones that repeated, 90 repeated, but 88 repeated the most often. So that would be our mode in this case. So 88 would be our mode. And maybe that's like, I don't know, like sometimes that's important data. And on a test, I don't know if that I would consider that to be all that important. Maybe it'd make me question it if those kids were all sitting together. Like they all got the same score. I don't know that they were cheating, but
It's harder to cheat now because everyone has tried everything.
yeah, a lot of things have been tried. I don't know.
Everything has been tried. You cannot come with something new.
All right.